Hello, Lovelace, and welcome to today's maths lesson. Continuing our work on fractions and subtraction of fractions. This time, though, we're going to see if we can cross over the whole one. So, can I subtract fractions through 1? That'll make sense, exactly what we're talking about in a moment. For now, a couple of warm-ups, 4 questions, pause the video, have a go. Okay, well, the first ones are both equivalent fractions. So 1 whole 1 is the same as 5 what? 5/5. I hope everyone got that one. And 4 whole 1s is the same as how many thirds? Well, it's 12. 4 times 3 is 12. So 12 thirds is the same as 4 whole 1s. Question 3. I've got 6.5. Take away 5/12. Now, the first thing I need to do is create a common denominator. So convert my half into 12s. So I've got 6 and 6/12. Take away 5/12. Gives us 6 and 1/12. And finally, 2 whole 1s, take away 1/3, leaves us with 1 and 2/3. Remember, a whole 1 is 3/3, so I've got 1 and 3/3, take away 1/3, leaves me with 1 and 2/3. Okay, 2 1/4, take away 5/12. Now, the first thing I need to do is convert my quarters into 12s. I need to create that common denominator. Okay, but our turtle friend doesn't think this one's possible. So let's see if he's right. Okay, so we'll multiply by 3. So we've now got 2 and 3/12. 2 and 3/12, take away 5/12. Now I've only got 3/12 here. So is he right? Is this one impossible? Have a think. Well, 2 and 3/12 is certainly bigger than just 5/12. So it must be possible to do this as a subtraction. So let's have a look. There's our 2 whole 1s and our 3/12. So 2 and 3/12, and we're going to take 5/12 away. Well, there's 3 of them, but then we're going to have to take some more from the whole. This is what we mean by subtracting through a whole one. So we're going to have to steal some from the 2 whole 1s. So there's 2 more. So altogether, we've taken away our 5/12s. And what are we left with? Well, basically, our 5/12s, we've taken away a 3/12, that section there, and then taken away 2 more. So altogether, we have taken away 5/12s, but we've sort of taken them away in 2 chunks. So we'll take away the 3/12s, leaving us with 2 whole 1s, and then we'll take away the 2/12s from the whole ones. So we're left with, so there's the 2 and 3/12s, take away 3/12s, which leaves us with 2, and then we're going to take 2/12s away from that, which leaves us with 1 and 10/12. There's our whole one, and there's our 10/12. And we can simplify that to give ourselves 1 and 5/6. Okay, so Turtle was wrong. We can do that calculation. It's just a little bit trickier because we have to go through and take from the whole number as well. Here's one, 2 and 3/12, take away 5/12. Same question, but this time we'll do it using the number line so we can see how we can find the difference between these two. So 2 and 3/12 is here. Okay, we've broken our number line down into 12s. So there's the 2 whole 1s, 1, 2, 3. So there's 2 and 3/12. And 5/12 is all the way down here. So there's quite a big gap between them. So let's do the steps and see how long it takes us to get there. Well, we can do 7/12 takes us from 5 to 1. Remember, a whole 1 is 12/12. So from 5 to 12 is a step of 7. Then we've got our whole 1, and then a step of 3/12 to get us to 2 and 3/12. So we just need to add these 3 together. And the 3 added together gives us 1 and 10/12, which simplifies to 1 and 5/6. So another way of representing the same calculation. So we've looked at bar models and we've looked at number lines. 2 more questions. Have a think. How would you approach these 2? Well, the first one, we've got 1 and 1/5, subtract 7/10. We need to create a common denominator. So first of all, let's turn our 1/5 into tenths. So we've got 1 and 2/10, take away 7/10. And if we think of a bar model, there's our 1 and 2. And we're going to split our 7/10. We're going to take away the 2/10 to leave us with 1 whole 1, and then take away the 5/10. So there's the 2/10, there's the 5/10, and we're left with 1, 2, 3, 4, 5/10, which is the same as a half. What about the 2 and 2/9? Take away 2/3. Again, job 1, let's create our common denominator. So 2 and 2/9 take away 6/9. We're going to multiply top and bottom by 3. Let's try that one on a number line. There's our 2 and 2/9 all the way up there, and then our 6/9 is down here. And we need to work out the steps taken to get from one to the other. So 3/9 gets us to a whole 1, then a whole 1, jump from 1 to 2, and then 2/9 is that short step from 2 to 2 and 2/9. Add them all together, and we get 1 and 5/9. Okay, so some of you might prefer the bar model, some might prefer the number line. Some of you, when we get to it, will be doing that as a straightforward calculation. As long as it is efficient, as long as it works for you and it's correct, then no problem at all. But it's nice to look at these different methods because in an exam, in a test, they might present it in a different way. So it's always nice to be familiar with the different ways in which a question can look. 2 more. 2 and 1/7 take away 6/14. Again, job 1, create a common denominator. In this case, I'm going to go for 14ths. Okay, and then for B, same again, 14ths. But for this one, which of these two do you think will break the whole? How do you know? Okay, well, as I say, common denominator. So we've actually got 2 and 2/14ths. Take away 6/14ths. And for this one, we've got 2 and 12/14ths. Take away 1/14. So this is the one that will break the whole because we're taking 6 away from 2, which will force us into the whole numbers. It's going to be 1 and something because we're going to have to use some of those 2. This one, however, we've got 12/14ths and we're only taking 1 away. So we don't need to interfere with the 2 whole ones. So it's that first one. That is the one that will break the whole. Right, your turn. Pause the video, have a go at these 3 questions. Right, here are your answers. If you've used the bar models, then take a look to see if yours match. If you've just done it as a straight calculation, your answer should be 1 and 11/12, 1 and 3/4, 1 and 2/3. Okay, those are the simplified answers. So on B, you might still have 1 and 9/12. And for C, you might still have 1 and 8/12. Always look to see if you can simplify them. Question 2, your answers are 3 and 1/8, 3, 2 and 7/8, and 2 and 3/4, or you might have 2 and 6/8 if you've not spotted the simplification. Okay, and then C, which ones actually do cross the whole? The first one and the last one. So 3.5 take away 9/10, that will cross the whole. The reason being is that 3.5 is the same as 3 and 5/10. So if you take 9 away from 5, you're going to have to go into the 3. And 4 and 2/5 is the same as 4 and 6/15. 6 take away 7 will require you to steal from the 4. Okay, so the first and the last are the correct answers. And for question 3, your missing answers are A is 2 and 11/15, B is 2 and 7/16, C is 3 and 7/12, D is 1 and 3/4. You might have left it as 1 and 9/12, but do look out for the simplification. E is 2.5 or 2 and 9/18, and F is 2 and 26/27. Okay, Dexter watches television for 3 and 2/5 hours during the weekend. Dora watches 13/15 fewer hours than Dexter. Okay. And Dora watches 1 hour of television on a Saturday. Your question is, how long does Dora watch television on a Sunday? So first of all, we need to work out how much television Dora watches over the whole weekend. So first of all, there's Dexter. We know Dexter watches 3 2/5 hours. So there's 3 2/5 hours. And we know that Dora watches 13/5 less. So this pale pink bar is how much television Dora watches in the weekend. But to work out what that is, we need to do a subtraction. We need to do the 3 2/5, take away the 13/15, and that will leave us with Dora's television watching. Okay, so have a think about that calculation. 3 2/5 take away 13/15. Well, there it is again. 3 2/5 take away 13/15. Job 1, create our common denominators. In this case, 15. So 2/5 becomes 6/15. We're going to multiply top and bottom by 3. So 3 6/15 take away 13/15. We'll take away 6 just to tidy that up, and then we're left with another 7 to take away. So 3 6/15 take away the 6/15, leaves us with 3 whole ones. And then the 3 whole ones take away 7/15, leaves us with 2 8/15. Okay, so Dora watches 2 8/15 television over the whole weekend. Now we know she watches 1 hour on Saturday. So what's left for the Sunday? 1 hour off that. So 2 8/15 take away 1, leaves us with 1 8/15 hours of television on a Sunday. Okay. Now the difference between a fraction and a mixed number is 3/4. The fraction has a denominator of 12. What could the fraction and mixed number be? Okay, so this is, say there's multiple answers to this one. Let's have a look. So this is what we're being asked. We've got a mixed number, and then we've got a fraction take away 3/4. Okay, so the fraction has a denominator of 12. Okay, so a mixed number, we know the denominator is 12. Take away 9/12, because 9/12 is the equivalent to 3/4. So we've converted this, we've created our equivalent fraction. 3/4 is the same as 9/12. So our mixed number, take away 9/12 equals something over 12. So what could the answers be here? What could solve this question? Let's start with 1 whole one. Let's go simple. And if we say 1 5/12, then what would our missing number here be? So we could split our 9 into 5 and 4. So take away the 5 to leave us with a whole one, and we're going to take away another 4/12 from the whole one, leaving us with 8/12. So there's one possible solution. Okay, there's lots of other possible solutions. Let's just go back a second then. If I put in 1 3/12, then I would be taking away 3 from the 9, and then a further 6 away from the 1, leaving me with 6/12. So you can see lots and lots of solutions. As long as you go back and check, as long as you check that the calculation works, then you've come up with a correct solution. Okay. So your turn now to have a go. Pause the video, have a go at these 3 questions. Right, our answers. For 4, here are some ingredients. We've got 2.5 kilograms of potatoes, 7 over 10 kilograms of cheese, and 1 2/5 kilograms of carrots. How much more do the carrots weigh than the cheese? So 1.2 or 1 2/5 take away 7/10 is going to be 7/10. There's your difference, because A common denominator is 10, so 1 and 4 tenths, take away 7 tenths, is 7 tenths. Jack uses 17 20ths of carrots. How many kilograms of carrots does he have left? Okay, he has 11 20ths. So we're going to convert to 20ths this time. So 1 and 8 20ths, take away the 17 20ths, and we're left with 11 20ths. And then finally, Jack uses all the cheese and the same amount of potatoes. How much leftover potatoes does he have? So for this one, you're doing 2.5, take away 7 tenths. Turn them all into tenths. So 2 and 5 tenths, take away 7 tenths, is 1 and 8 tenths, which is the same as 1 and 4 fifths. Question 5. Eva's doing the long jump. Her first attempt, she jumps 3 and 2/9 meters. The second attempt is 2/3 of a meter shorter than her first. How far is her second attempt? 2 meters and 5/9. So 2 and 5/9 of a meter. And then finally, there's going to be multiple answers for this one. So I will take a look at your tapestry. The difference between a mixed number and a fraction is 7/8. So 7/8 is the answer. The fraction has a denominator of 16. What could the mixed number be and the fraction to give two possible answers? So my suggestions are 1 and 1/16. Take away 3/16 would give you 7/8, and 1 and 3/16 take away 5/16. Okay, so those would give me 7/8 as an answer, or 14/16, say for this particular example. Okay, so if your calculation results in the difference between the two being 7/8 or 14/16, then you are correct. So well done. Okay, that is the end of today. Take care of yourself. Look after those around you. Stay safe, and I will see you very soon.